2 times 2 is 4.
This video is a review of quadratic functions. It's going to go over the basics on the equation and how to graph it. For those of you that don't remember, well, the first thing we need to talk about with quadratic equations is standard form. And standard form is the equation y equals ax squared plus bx plus c. And we use standard form to graph. We use it whenever we do quadratic formula. It's the one you're mainly going to use. Now, in order to graph from standard form, we're going to do a couple of things. And the first thing we're going to do is find the vertex. And we do that by plugging it into the formula x equals negative b over 2a. That's going to give us the x value of our vertex. I'm going to do an example off to the side here. How about y equals 2x squared minus 4x plus 3. All right, so if I do x equals negative b over 2a, this means x equals negative, and I'm going to put b in parentheses here because b is also negative. Negative 4 all over 2 times a. And a here is in front of x squared, so it's also 2. A negative and a negative make a positive. 2 times 2 is 4. So I get the x value of my vertex is equal to 1. So I know my vertex is going to be at 1 comma something. I don't know what the something is yet. And the way we find that is to find the y value, you plug x in to the original equation. So I'm going to plug 1 into my original equation up here. Y equals 2 times 1 squared minus 4 times 1 plus 3. Y equals 2 minus 4 plus 3. So 2 plus 3 is 5, minus 4 is 1. So this is telling me that my vertex is going to be at 1, 1. So if I take this example here, didn't mean to grab that. If I take this example and let's say I throw in a graph. This is telling me that the vertex of my parabola is at 1, 1. So right there, there's the vertex of my parabola. After we find the vertex of the parabola, we're going to find a thing called the axis of symmetry. And the cool thing is we've already found it. It's just the line x equals whatever your x equaled. So x equals negative b over 2a. And what this says to do is that through the vertex, you can draw a vertical line. And that vertical line is going to be my axis of symmetry. It's going to be the mirror that it reflects across. It's not part of the graph. It's just used to help us graph. So after we have found the vertex, we've drawn in the axis of symmetry, then what we're going to do is move one x value right or left. Sorry, it's lagged up here. Left and plug in. So I'm going to move one x value over. So I'm either going to move from my line over here to 2, or I'm going to move this way to 0. Either one. You can plug in either one. The great thing is that you're going to get the same thing if you plug in 0 or if you plug in 2 because they're symmetrical. So I'll plug in 2. Let's go to my original equation. 0 would be easier, but just for sake, I'll plug in 2. So I'm going to plug in 2 instead of 1. I get 8 minus 8 plus 3, and we can see that that would equal 3. So at 2, my y value is 3. And since that axis of symmetry is a mirror, if I'm one space away on this side, I have to be one space away on this side. Let's go one more. So I plugged in 2. I'm going to move over one more x value, and I'm going to plug in 3. So 9, 18 minus 12 plus 3, I think that equals 9. So at 3, it equaled 9. And if I'm 2 spaces away from my axis of symmetry on this side, I have to be 2 spaces away on this side. And we can see that if I plugged in another number, it's not going to be on my graph. It's going to be off my graph. That's when you stop. Well, you stop when the next one's going to be off the graph. And then I just come in and draw a smooth, continuous graph like that. And that's how we graph a parabola. Now, there's some features that we need to probably talk about on this. The first one is y-intercept. So the y-intercept is where it hits the y-axis, which is right here. So my y-intercept is 0, 3. What about my x-intercept? Where does it hit the x-axis? Well, it doesn't hit the x-axis. It's above the x-axis. So we would say it does not exist. Another thing they may ask us to do is to say, where is the function increasing and where is it decreasing? Okay, so increasing and decreasing. We always look at this from left to right. So if I'm looking at my graph and starting from left to right, I can see that right here, it's coming down. It's going down from left to right. And I'm going to write this using interval notation, which is simply to say, I'm going to put a parenthesis, and then I'm going to say, where does it start and where does it end? Well, it starts off my graph. It starts way over. I just care about the x values. So it starts way, way off. So I'm going to say it's decreasing from negative infinity all the way until it hits the vertex. Because at the vertex, now all of a sudden, this function starts going up. So I'm going to say it's decreasing from negative infinity all the way until x equals 1. And I'm going to say it's increasing from 1 all the way, and it goes on forever and ever, so infinity. Another thing they can ask us about is the maximum or the minimum. Well, we're looking at our graph and we see that it goes up forever and ever and ever. There is no maximum, there is no top, but there is definitely a minimum. And the minimum is right here at our vertex. So the minimum is at the vertex. So I would say that there is a minimum at 1, 1. That's our vertex. And with a parabola, the vertex is always going to be the minimum or the maximum. If the parabola opens down, it's going to be a maximum. If the parabola opens up, it's going to be a minimum. Okay. So that's the basics. Let's do one more. We'll work one more together. Make it a little more difficult. Oh, let's do that and that. So y equals negative x squared plus 6x plus 3. All right, so I'm going to throw myself a little graph up here. I need that. So the first thing I do is I find my vertex. So I'm going to need to do my x equals negative b over 2a. So x equals negative 6 all over 2 times negative 1. So it's negative 6 over negative 2, and a negative divided by a negative is positive. So the x value of my vertex is 3. To find the y value, I'm going to go ahead and plug it in. Make sure you put it in parentheses. And the reason I say that is because if you take this first term here and don't put it in parentheses, or even worse, you put the negative inside the parenthesis, you're going to get the wrong answer. Because what this says is 3 squared, then take the negative of it. If you put the negative inside, it's squaring negative, and you're going to get the wrong answer. So I like to put in parentheses. I overuse parentheses. It's better. 3 squared is 9. 6 times 3. And negative 9 and 18 is 9, plus 3 is 12. So my vertex is at 3, 12. Well, that's dandy since I made a graph that's 10 by, but 3, there's 10, 11, 12. And that's my vertex there at 3, 12. And I can draw my axis of symmetry in, which is the line x equals 3. Then I'm going to move one spot over. Now, I could either plug in 4 or I can plug in 2. I'd probably choose to plug in the smaller value. So y equals negative 2 squared plus 6 times 2 plus 3. Remember, you could plug in either one. You could plug in the 2, you could plug in the 4. You're going to get the same answer. So that's negative 4 plus 12 plus 3. And that looks like it equals 11. So at negative 2, or at 2, we get 11. And we mirror it to the other side. If I'm one away on this side, I better be one away on this side. Move over another space. Plug in 1. If you're using a TI calculator, you can just go up and hit enter on the last equation you spent and it will bring it back. And then you can just arrow over and change the 2 to a 1. I'm doing this longhand, obviously, so that's not going to work. And I get 8. So when I plug in 1, I got 8. Move over again. I'm going to plug in 0. 0 is great, because if I plug 0 into this, then this one becomes 0. This one becomes 0, and all I'm left with is the 3. So at 0, I get 3. I'm 1, 2, 3 spots away here. I better be 1, 2, 3 spots away there. Now you have a choice. I can either plug in -1, or if you don't like working with negatives, which a lot of us don't, I could also plug in 7, because 7's the next one. Just because I started going this way doesn't mean I have to stay that way. I could jump back over and plug in 7 if I wanted to, and I'm going to, just because I like dealing with positive numbers. Once again, you don't have to. You can plug in -1 if you're comfortable with that. -49 plus 42 plus 3 looks like that's going to be -4. So at 7, 1, 2, 3, 4. 1, 2, 3, 4 away on that side. 1, 2, 3, 4 away on that side. Let's see. 1, 2, 3, 4 right here. All right. Now, if I look at the distance between, he really wants to pop that up. If I look at the distance between this and this, I can see that the next point's going to be off the graph. Hey, good news. I can quit. So I'm going to come in here and I'm going to draw you stupid thing. So I'm going to draw my smooth continuous curve up through that point, make it a U shape at the top. Do not make it pointy, because pointy graphs are absolute values. And I get a graph that looks like this. If I was asking, when is it increasing and decreasing? Well, it looks like it's increasing on this side and decreasing on this side. So it's increasing from, as I go this way, from -infinity, that looks like an 8, -infinity, all the way till our vertex, and our vertex occurred at 3, and then it's decreasing from 3 to infinity. If I asked about a maximum or minimum, it's going to have a maximum at 312. If I asked for a y-intercept, I could say that there's a y-intercept at 0, 3. If it asked me for an x-intercept, well, that's a little harder, because it doesn't go through an exact thing. But I could say there is one between 0 and -1. So that's saying there's going to be one right in here between 0 and -1. And there's also one right in here between 6 and 7. If I took to my calculator, I could hit trace and I could find that, or go into the table. But it's good enough to say that's where it would exist for now.